This presentation will provide information on common aircraft engine instruments and what they monitor. Modern-day engine data monitoring and logging tools create a history of data in which trends can be detected. This is helpful with preventative maintenance and keeping the engine running for years to come. There are two parts to any instrument system: the sensing mechanism and the display mechanism. Information is relayed from the sensors to the indicators via electricity or direct pressure sensing via pneumatic or oil filler tubes. The engine instruments give the pilot information about the health of the engine and how it is performing during flight. This information is also required to keep the engine running within specified operating limits so that it will remain reliable throughout its lifetime. In earlier years, aircraft were equipped with analog gauges. Modern, more sophisticated aircraft are outfitted with digital computer systems. These systems have proven more effective because of their ability to deliver more accurate and precise data, though their dependability is often challenged. In a gas turbine engine instruments generally indicate fuel flow and temperature, as well as engine speed and percentage of normal shaft speed. In a reciprocating engine, instruments generally indicate oil pressure and temperature, cylinder head temperature, exhaust gas temperature, and sometimes manifold absolute pressure. Some common engine instruments are RPM, pressure, and temperature gauges. Fuel level and flow gauges are sometimes integrated in one unit. In multi-engine aircraft, there is usually a set of gauges available per engine stacked next to each other. Turbine gas temperature is sensed at the power turbine inlets by thermocouple probes. These signals are averaged and routed through the engine control unit, processed by the data signal converter, and transmitted to the cruise station indicators. The exhaust gas temperature instrument is mainly used for leaning the engine. FADEC-controlled fuel-injected engines cannot live without this important measurement since they regulate the amount of fuel per cylinder in combination with RPM and MAP. This is done to obtain the best mixture for the power requirement without causing detonation in the cylinders. Temperature instruments use a thermocouple to measure temperatures. A thermocouple consists of two dissimilar metals welded together, and they form the sensing probe, the hot junction. The cold junction is at the instrument. When the hot junction is heated, a small voltage will exist between the hot and cold junctions inside the instrument. The scale of this instrument is calibrated in Celsius or Fahrenheit. Almost all aircraft are equipped with oil pressure indicators. Pressure signals are taken from the engine oil system transducers and displayed on the cruise station indicators. Power turbine and main rotor speed indicators are often seen as a triple vertical scale instrument. The engine power turbine drive shaft sensors transmit pulse signals to the engine ECU, where they are computed into speed signals and then sent to the cruise station indicators. The middle scale registers main rotor speed and receives input directly from a magnetic pickup type tachometer generator on the transmission. Torque indicators are often provided as a dual vertical scale instrument with dual digital readouts beneath the scales, though this is not always the case. The engine torque sensors send pulse signals to the engine ECU, where torque signals are computed and sent to the cruise station indicators. Though cockpits of today's aircraft are becoming digital and more electronically driven, the importance of understanding gauge readings and knowing how to troubleshoot or react in the event these instruments begin to act abnormally or produce alarming values has not changed.